Hello, everyone. Another speaker tonight who dropped out, but conveniently, I have just given this presentation. Hopefully, I remember it still at AWS Community Day down in San Francisco, and basically a bunch of leaders got together to lead different user groups and give presentations. So hopefully, you'll like this, and that's why it says AWS Community Day down at the bottom there. So my topic today is security for complex networks on AWS. And I wanted to start out by telling you why I should care about security. Everyone knows they should care about security, but there's still a lot of challenges getting companies to actually invest in security and making sure, especially IoT products come out and are secure and other products. And so this first number is $1 million. This is what the estimated losses were in the target breach. I actually did a paper on the target breach, and this number was much lower at the time I did the paper. And I do have notes in these slides, and I have these slides published online, so you can look at all this later if you want to. But some people came out and they said, oh, you know, the target breach, all these breaches, people don't care because the stock prices aren't falling, and people are still going to the store, and nothing's happening to the people, or to the credit cards. People are getting all their money back, so why do we care about this? And I look at this number and I say, this is a really big number. I think this number does matter. I look at this number and I think, how many target stores could we build for $1 billion? How many people could we employ for $1 billion? How many cool new software projects could we do for $1 billion? So for the people that say, oh, the breaches don't really matter, I think this is a lot of wasted time. We just had another settlement like a month ago for $18 billion. So they still have people invested in trying to deal with all these settlements and all the aftermath of this breach. To me, that's a big waste of time and money. I also would recommend that you take a look at this book, if you can. This is a book about the first cyber weapon. I think there's a lot of reasons why we should really care about cybersecurity. I hope I convince you with the rest of my slides that there are things going on that we should be more aware of, be looking at in our logs. This is another book that I recommend if you've ever heard of Brian Krebs. He is a famous security blogger. And this book is about, there are a lot of spammers a few years back, and they're still going on, but it was really prevalent about 2005. And I was looking at my logs, and or my email, and I was saying, why am I getting 900 spam messages per day? It kind of ticked me off. I was hosting some websites, and I started digging into these messages and looking at the email headers. And I started correlating. I would get 5 of the same messages, and I would look at all the email headers, and I realized that these emails were coming from companies like Microsoft and Google and little companies and big companies. And I was like, wow, all these companies are hacked and they don't know it. So I started trying to email the companies or do something about it, and no one would listen. Everyone's like, oh, it's just spam. Well, if you read this book, you'll find out why it's not just spam. There's a lot of reasons why you should care about what's going on there. And on that note, I'll tell you a story of a breach. So I started digging into that, and then I went on to build a hostel booking site for a company. There was a guy down in Australia. He didn't want to pay the high booking fees to some other companies, so he said, hey, will you build me the site? And I said, yeah, I'll build you the site for free, and I'll just take a cut of the bookings. So that's how I got paid, like 10% or something. And so I set up the site, and it was cool. I started getting money, and I was like, cool. It's a little extra side money for me there. And all of a sudden, the booking stopped. And I'm like, that's weird. They were, something's wrong there. They were coming through. Why did they stop? So I started digging through the logs. I didn't know much about security, and I moved to a managed hosting company from a co-location facility, thinking like they could help me with security, right? Because I was starting to become aware this was an issue. So what do you do when the software doesn't work? You restart. So I restarted the server, and I got a booking. And I was like, oh, well, maybe something happened, memory, who knows what. And so then I waited, and the booking stopped again. So I was like, huh. So I restarted, and I got another booking, and the same thing happened. So I thought, well, it has something to do with that restart. So let me look at that a little more closely. So I was running a Jetty web server, and I restarted it in a command window so I could see all the traffic coming online. And I noticed that when I restart, I would get hit by 5 IP addresses from all over the world, different ones every time. Well, that's not right. So I went to my hosting company and I said, something's wrong with my web server. Can you help me? Thinking that that was part of their job, but I don't think it really was. And they said, sure, we'll help you out. And they came back and they said, we ran a virus checker. It's fine. And I thought, it's not fine. There's clearly something wrong here. how could you say it's fine? But they didn't want to help me further than that, so I went ahead and started thinking, well, maybe if I look at those network logs a little more closely, that would tell me something. So I asked them, I didn't really know what I was talking about, so I went to the first guy and I said, can you turn on my outbound firewall logs? I was very hesitant. He said, oh no, that's just way too much data, we can't do it. I was like, oh, I have this little tiny website, how could that be too much data? Didn't make sense. So waited, got till the next guy came on shift, and then I was like, turn on my outbound firewall logs. Like, I know what I'm talking about, right? Because I figured out the lingo. And he said, okay, sure, he turned them on. So I looked at those logs, and in those logs, I noticed that I had a ton of traffic on port 25. And as most of you probably know in this room, port 25 is what is used to send email, which is related to that spam book I just told you about. So, but I didn't know at the time how to fix this problem, so I was like, oh, now they'll believe me. I went back to my hosting company, I said, look at all this traffic, I'm not sending it, I even turned off my mail server, it's still going. And they're like, no, it's fine. Okay, so I go back to my server, not knowing what to do, not knowing anything about incident response, and I just thought, well, it's something running on the server, so I just start shutting things off on the server, and after I locked myself out and called them like 3 times to let me back in, and figured out what services were what, I was able to shut that down. So there's more to that story, which I can tell you another time, but why am I telling you this? I'd like to say the network doesn't lie. And I'm going to explain this further, but in the case of this particular breach, maybe a really good security person, which I was not at the time, could tell you, look at that server and say, oh, here's what's wrong. But at that time, that particular hosting company's solution was to run a virus checker, and the computer told it nothing. But when you look at the network doesn't lie. The logs are there. They're telling you something is going on, and the network can't lie, and I'm going to explain that. When you send a letter, you put a return address on the letter. And that return address will help you. You could probably live without it, but without that return address, if your letter doesn't get to the intended recipient, you won't get a notification telling you that something went wrong. And if you don't have the return address and the person you're sending the letter to doesn't have your return address, they can't send email back. So it's probably a good idea to put that on there. Now, if you don't put the recipient address on the mail, it's not going to get where you want it to go. It has to be there. And if you put the wrong information in the letter won't serve its intended purpose. There's no point to that. So network packet is the same way. This packet is in hex, but this hex is just a way to send data in a compressed form over a network, so it's faster. You can convert this back to something human readable. And in this packet, you will see a source address, a destination address, and a payload. And they have to be right, otherwise what's the purpose of sending the packet? There's a few exceptions. Yes, there's DDoS attacks and things like that, but in general, if someone's trying to send malware to a machine, it has to have the right information in the packets. And yes, they can be really tricky and obfuscate the data, but at the end of the day, if you have all the information, you can put it back together and you can figure out what happened. Oh, and one other note on that, on your computers, the reason why I say the network doesn't lie is because there are things called kernel mode rootkits, and they will embed very deeply into your machine, way down in the operating system, and you can't see what's going on. You will get false information when you look at the processes running on your computer, when you look at your memory and your CPU. All of that could just be lies. And the other thing is there's something called the blue pill, which is somewhat like a hypervisor that basically wraps your system. Someone else is totally controlling you, you don't know it. But the network will have to tell you the truth. So let's look at some packets, some random network information here. So I have this website that a long time ago, I told this investor, like, oh, there's a lot of stuff going on in security, you should invest in that. It was like 10, 15 years ago, and he said, go write a blog. Okay. And I didn't really know what I was doing, but I started tracking what was happening on the network and blogging a little bit about it. And so I haven't written a lot on this blog, but recently I spun up a WatchGuard Firebox Cloud. That's the company I work for, and we build a UTM appliance. And I just put it on AWS. It's an instance you can get in the marketplace. I didn't tell anyone about it. It's just me. Put it up there, and in one day, I had a whole ton of traffic. You guys are probably somewhat aware of this. And I grabbed a sampling of this traffic, and I just quickly analyzed it, and probably some of it's wrong. I did it really fast. But it gives you an idea of just in a short amount of time how much traffic is hitting that instance. And you can go look, if you want to go look, it's on this random internet connections at blogspot.com is out there. And another thing you'll notice in this list of packets is I split them up by, there's some links there. And what these are regional registries for different parts of the world. And if you're not aware of this, just want to let you know, you can go out there and plug in an IP address, and you can get back information about the network that's hitting your systems. And it could be, a waste of time to sit there and do that all day, although I've been known to do that. But what you can do is you can learn about the different networks that are hitting your systems. And if you read that spam book, there was a time where, when I was really into this, you could find a particular network that's really evil and just block that whole network. And that's what these sites can help you with. They can help you understand, like, oh, that particular network is sending me a lot of bad traffic. Maybe I want to block it. Another thing that you'll notice, there are a bunch of different things I listed out there, but this is something called a port scan. This is a kind of a blatant thing that's really easy to spot in your logs. And what you'll see here is that there's the same address hitting your systems over and over again on different ports. And what they're doing is they're going through and they're like, is this port open? Is this port open? Is this port open? Why would they want to do that? Because once they find an open port, they will use the vulnerabilities that have been announced, like the vulnerability on port 445 that was using WannaCry. It's old. No one should have that exposed to the internet, but obviously a lot of people do. And so they find this open port, they figure out how to get malware onto that host. One thing that's interesting is almost always that malware will call home. It has to call home and tell the computer that's infecting it, hey, you got me, you got someone. And what happens then is there's something called a C2 server, or a command and control server, and it will call back to that server, and that server will start sending commands to that host, that infected host, and tell it what to do next. Then what happens? It goes out and tries to find another victim. So like in the case of WannaCry, it was a ransomware that just automatically went out and scanned the next host and the next host. But sometimes these hosts are controlled, and the command and control server will be going out there and saying, hey, try to scan all the hosts around you, or something else on the internet. And then pretty soon you have a whole bunch of infected hosts, and it looks something like this. And this is called the botnet. You may have heard this before. Whose servers are these? Are they the attacker's servers? No, they're yours and mine. There are IoT devices and our servers, and they're all the things that we're not protecting. And they're being used to do malicious and evil things. So how can we protect ourselves? Here's what not to do. Remember I told you to put that firebox up there on the internet and it got hit with all this traffic? Don't put all your hosts on the internet. If you have every single host out there on the internet with an open network, they're all getting bombarded, and not only is it a security problem, in the case of Amazon, you're going to be paying extra money too. Here's something that's a little bit better. Here we have subnets. So this is a typical application architecture. You have a web tier, an app tier, and a data tier. And your web tier is your tier that's exposed to the internet. Then your app tier is not on the internet, nor is your data tier. And you have something called a route table. Now, I've seen a lot of people just leave their route tables in the default, but your route tables are actually security tools. You can say, my web tier can only talk to my app tier. My app tier can only talk to my data tier by setting up your traffic routes so that the data can only get between those places. So in this case, Mr. Evil is out there on the internet, and he's trying to get at the app tier, and he cannot directly connect to that app server. So the next thing you can use NACLs. And NACLs are on a subnet. So they don't let data into a subnet. They're your rules protecting your subnet. So anything in that subnet cannot get in. So if you had a rule blocking 70/70/70/70 on your NACL, then Mr. Evil can get in, or a particular port. So here are some tips for subnets and NACLs. You want to make your subnets as big as possible. The reason for this is because it's very difficult to manage a gajillion cyberblocks. I did this at Capital One. We had over 70 VPCs, and all I did all day long was fill out a spreadsheet. It's not fun. And it's kind of a waste of time. The other thing is, if you have a complex network, which is what we're talking about here, you're probably going to have a firewall in-house, and you're going to have rules in your in-house firewall and in AWS, and you're going to have to manage those rules back and forth and add all those CIDRs. And when they change, you're going to have to change and update them. It's a very time-consuming thing. So there's a really good talk out there from Rob Alexander, the solution architect from Amazon at re:Invent, and I have it in my slides. And he talks about this. And basically, you want to create big blocks of subnets. So in the case of my last picture, you might have a subnet for your web servers and a subnet for your database servers and your application servers. If you make too many subnets, you could run out of IP space. If you're trying to make a subnet for every application, which I've seen done, then you probably have a subnet. There's a limit to how small they can be. And you probably have a couple of hosts in there and a bunch of wasted IPs. And if you have many hosts or applications, you're just going to have a lot of wasted space. Whereas if you consolidate those all into one big subnet, obviously you're going to be able to use that space more efficiently. And then maybe you say, well, I'm just going to make my subnets really small. I'm not going to waste any space. Well, there's a problem there because Amazon only lets you go to a certain size. And additionally, let's say that application grows and you need to make it bigger. Now you have to go back and change your CIDR rules and your firewall in-house, and you have to go back and reallocate that subnet, and you have to take your application down in the meantime, and you probably have to move to a completely new CIDR block because you have other things around it. So it's a really good idea just to think this through up front and make your subnets big. You also want to understand your route table so you know where your data is flowing. I just mentioned that. And limit your routes to what is required. Really use those route tables. Limit your internet gateway routes. This is where your data, the things are getting in from the network, or from the internet. So make sure you limit those. And NACL rules are limited to 20. You can increase that somewhat, but they're going to be limited. So you probably want to use NACLs for big, broad rules that rarely change. Security groups are the next thing we can use. So security groups are cool because they reside on the hypervisor instead of on the instance. So if you think about a host-based firewall, if that host gets compromised and there's privileged escalation and you're using IP tables, guess what? The malware can just change the rules. The difference with the subnet is it resides on the hypervisor. So if your malware gets onto your host, it's not going to be able to change those subnet rules. And the subnets are the security group rules. And you're going to want to try to make a whitelist of your security groups as much as possible. I'm going to explain why. So here are some ideas for structuring your security groups. It's a group of rules, not a group of instances. This confuses people sometimes. Don't use your subnets, your security groups for grouping instances together. They're network constructs for protecting your instances. So it's a group of rules saying, this is my application. This is what my application is allowed to talk to. You want it to be a whitelist, and use IDs wherever possible. CIDR blocks, again, you have to manage them, maintain them, change firewall rules. Security group rules, IDs are much easier to deal with, especially if you're taking security groups up and down. Abstract out your common rules. So there are a lot of common rules that all the instances will need. There's no point in replicating those in every single security group. You're going to want to write multiple security groups. And then you have a common group, but make sure it's only your common rules. You don't want to have this common group turn into the kitchen sink, and pretty soon all your instances are exposed to way too many things, and you no longer have a whitelist. Security group rules are limited, and some ways to deal with that are consolidate your CIDR blocks when they're contiguous. So instead of creating two rules, if two CIDR blocks are right next to each other using the same port, make sure you make that one rule. And you want to check out products that you buy prior to purchase. Some products use a lot of ports, and people don't always look at that when they're buying a product. Additionally, I've seen places where everyone in the world wants to run a monitoring software of some sort. Why not pick one and use it company-wide so you don't have to open a whole bunch of ports? And you may need to re-architect things to get around limits. So this is another thing I've seen where you have something like Active Directory, a really complex structure. And Active Directory requires a lot of ports, right? And so you have all these different Active Directory servers. One way to deal with this is to kind of have a proxy where you consolidate that data and replicate it into AWS, and then have your instances only talk to one set of instances. Okay, so we've done all that. So here's our example. We have subnets, security groups, we have route tables. We have this all set up, and we're secure, right? Not quite. So the next thing you got to worry about is proxies. So proxies have good purposes, but they can also be used for evil. So if a malware can get onto a host and set up a proxy, it can make the traffic from that malware look like it's good traffic from a good host. Here's what that looks like. A proxy will basically wrap traffic that's not supposed to be getting through your firewall, and it'll look to your firewall like it's good traffic. So in this case, you might have some bad traffic that is wrapped in 443, and it looks like it's just web server traffic, and the firewall says, yep, that's cool, that's a port's allowed, it's coming from a host that's allowed, and it looks like a good protocol, so let it through. Besides proxies, there's also different kinds of tunnels. There's reverse shells, and if you read the target breach paper, you will see that data was exfiltrated on ICMP packets. So there's a lot of ways that people can tunnel data out of your network. So how do we protect ourselves from it? First of all, only allow the direction that you want. I've seen people make the mistake of, oh, I need to open up port 80 for my web server, so I need to open it both ways. That's not true. The traffic is initiated from a server to port 80, and it's returned on ephemeral ports. Basically, the ephemeral ports are high-numbered ports that track the different clients that are connecting to that server, and 80 is where the traffic is coming in. The request is coming in 80, going out on ephemeral ports. It looks something like this. There are different ephemeral port ranges depending on what application you're using. And some protocols will go out back and forth on the same port. FTP might have its separate data port, so you have to understand the protocol you're using and the operating system you're using. And there's some more documentation from Amazon on this as well. But basically, in this case, we would say we have traffic coming in on 443 and going out on ephemeral ports, and we may only allow those ephemeral ports out. And if we're sending out 443 data, maybe we block it, or maybe we say it's only allowed to these particular setters. And then what happens? Mr. Evil comes in, he gets some malware on the web server, he tries to call out, doesn't work. This is important for things like WannaCry, where you have a ransomware, and the ransomware is getting in on port 445, and it's going back out on port 445 to back to the host. So this is one thing we can do to help. The other thing is, if you have actually thought through your network and really tried to set up whitelisting, you can look for deny log entries in your traffic. Because just think about it, what is a deny log entry? Either something's misconfigured or it's doing something it's not supposed to. So we can really look for those. And if you just turn on VPC flow logs, it's really easy. Anything you see, anytime you see a deny entry, you should be questioning, what is that? Why is that happening? So here's some other patterns you can look for. You could have traffic from countries that you don't do business, like why am I connecting to this? In the case of the target breach, some of the traffic went to Brazil. Target's not in Brazil, I don't think. So you should be able to look for things like that. Excessive connections over time might be something suspicious. Many connections in quick succession, that's like the port scan I just showed you. If something's hitting all these different ports, that's a little odd. Excessive connection length, a lot of data going in or out, especially if these things change. If you see something that's anomalous, it's really important. This one's hard, but if you could check encrypted connections from keys you don't know about, this one's a tough one to do, but a lot of malware is sending data out of your network encrypted, which makes it really hard to look at the payload and try to figure out what's happening. And you can have a honeypot. Like, for example, I set up the firebox. You definitely want to, if you do this, not connect it to your normal network, because otherwise those proxies will get in and your honeypot will kind of bite you there. So gotta be careful with those. Some other considerations are look at which services require you to go out to the internet versus be on your internal network. So if you're trying to protect your data and you want to keep everything private on your internal network, you have to make sure you understand what traffic is going over the internet versus maintaining on your private network. NTP is, by default, on all AWS instances, is going to go out to public IP addresses. Well, I just said we don't want to have internet routes and all their subnets, so what can you do? You can set up NTP servers on AWS. For example, Firefox Cloud Connect as an NTP server, or any NTP server you set up, and then have all your hosts to that, and have that NTP server in your internet tier. DNS, everything needs DNS, so you're going to feed that through, or you're going to use Amazon, or you're going to use your own Active Directory. The good kind of proxies are the proxies where you have your traffic going out to the internet and you want to check that the URLs are valid. You say, well, my user can go to these URLs and not those URLs. Where are you going to put that proxy? I have seen that put back in the data center and backhaul all the traffic. And the problem with that is, A, you're paying for outbound costs. And the second problem with that is you could overload those proxies because they are not scalable like things in AWS. So that's another consideration. And you have to think about the Amazon IP ranges. If you are trying to whitelist, you have to decide where are you going to put those IP ranges, how are you going to handle that, because a lot of the Amazon services talk to them. So you have to figure out your strategy. Installing software packages, that's related. Amazon Yum, if you're using it, works on S3. And I have a blog post about that. So if you want to know more about that, I would say go read that one. I have time to go over all that now. And I mentioned the other two. So I have a question for you. Is it easier to patch all your hosts, or is it easier to block a network flow? Depends on your network. So you have to understand all the paths that your network can take. I like to say data is like water. If you open a hole, it will flow there. So if you don't know where all the holes are in your network, you may think you're blocking a port, but if there's another escape route, you don't really know if you're blocking or not. So this can get tricky. So how do we deal with that? I would say limit your entry and exit points. Think about a castle. There wasn't 500 doors on your castle, there was one, and they heavily guarded it, and they monitored it. So this is a good example. How do we do that in terms of a network? So you could set up a security checkpoint or a security host anywhere you have an internet route. Don't let any of your hosts have a direct route to the internet. Put something that handles security, that checks your packets, whatever that is, in between that host and the internet. And I have a list of a bunch of them here. I won't have time to explain them all. I would recommend that, there's a lot of security classes out there. I took classes at SAMS, and I took the boot camp there, and it explains a lot of these things. One thing to keep in mind on this list I do want to call out is your system that you use to deploy software to AWS. This is one of the ways things are getting into your network. So how are you going to secure that? How are you going to make sure you don't have malware in those packages? Well, that, in the case of Target, the deployment system was used to actually deploy the malware on the POS machines. So this is an avenue that can be taken to get bad things in your network. So how can we make our jobs a little bit easier? Amazon recently came out with this transit VPC blog, and I was actually going to write about this before I knew this existed. This is a good idea if you can structure your network in such a way that you can filter all your traffic that's crossing network boundaries through a single VPC. And there are multiple reasons, not just for security. I would refer you again to the blog or to the video by Rob Alexander. He talks about this. It's called One-to-Many. And there are management reasons why having every single network connect to each other is very complex. But from a security standpoint, I like this approach because if you could filter all your traffic through a transit VPC, you could have that particular VPC handled by people who really understand security and networking. And that is the point where things will traverse and get to and from the internet. You could heavily monitor that, especially if you have 70 VPCs. How are you going to monitor 70 VPCs? You can imagine that would be very complicated. So how can we kind of structure our network to limit the points at which we have to do heavy monitoring? Another thing I just want to remind you, if you have a control but anyone can change it, the control is useless. So I'll give you an example. Someone told me, oh yes, we have an S3 bucket and we have a role and only this instance can get to this bucket with this role. I said, oh, who can spin up that instance with that role? So if anyone can spin up an instance with that role, then they can write an instance with some malware on it to do something or some action you don't want and just use that construct. So when you're thinking about your network, you want to think about locking it down so that only the appropriate people can change it. And some things you can do is you can set up a company account. I like to do that with nothing in it that could get hacked. It's just for consolidated billing and for IAM policies. And now AWS organizations look really cool. You can set policies throughout your organization. Highly recommend AD because, first of all, developers don't treat keys like passwords. They are. They email them. They don't understand. And secondly, when you have an organization and someone leaves and you have a bunch of keys floating around there, how are you going to get those back? How are you going to say, oh, that key's not valid anymore? If you're using AD, then when the person leaves, you just turn off their AD account and they're locked out of everything. And additionally, that works if they change roles within the company and you've structured your AD with roles. But AD is honestly, the password is not as good as those keys I just told you about, so how do you deal with that? MFA on everything is really good. MFA for getting into the console, using the command line. I have an example out there using the command line. It's a really good idea. Set up your roles and policies. I would say that in general, networking, implementing a network is not hard. Like going out and writing some code and creating some NACL rules, that's not hard. Implementing a secure network is hard. There's a lot going on there. And I don't think that a lot of developers are trained to be network security professionals, but that could change. And I think everything is converging and it will change. But at this point in time, I'd say it's a good idea to have a security team that really understands these network rules and can really set this up and make sure things are secure. So here's some tips coming from managing a lot of networks and a lot of people every day just wanting their networks right now. Here are some tips that I learned. First of all, if you try to control everything too much and your network implementation becomes a bottleneck, then there will be a revolt. It goes up to management, people complain, and pretty soon you lose control of everything. And I've seen this happen. So how do we get around that? Create rules that people can follow. And so one example is to set up a rule like allow to a web server, to an app server, to a DB server. Anyone who follows that pattern, they immediately can build. They don't have to go through some external review process because it's a standard pattern and people can understand that. I also would say don't throw network implementation over the fence to the developers because they'll come in the next day. You did it in the middle of the night, they come in the next day, it doesn't work, and they're like, oh, networking people are no good, and they get mad. So the way around that is to really have your developers there when you're implementing the network. A lot of times there's tricky things about the networking that the developers didn't understand. They didn't give you all the rules, or maybe you don't understand their application completely. So just have everyone there to test and implement at the same time. Definitely you want to QA and pen test your network just like anything else. A lot of times this gets overlooked, but we are moving towards software-defined everything. So treat it like software. And then another idea was if you have your networking in a GitHub repo and you have developers who are itching and they want to learn and get involved and they want to help you go faster, you could let them fork that GitHub repo and propose networking changes. And then if they do something that's not right, you could explain to them at that time, oh, thanks for helping me out, but that's not right, and here's why. Another thing is to automate, but do it wisely. You don't want to just create a new console that's not really automation. Automation is checking code into source control and testing it and using the software development lifecycle to push out your changes. For accounts and VPCs, there are some things to think about in terms of your networking. You may want to design your accounts to make your life easier, just to break them down so that different people with different permissions have different accounts. You might want to have a sandbox account. So if you have automation and particular security rules, people still need a chance to be able to go and try things out. So I really like to have a sandbox account where people can just go click around and try new things. And finally, if you have someone that's coming to you and they say, we need to push this thing to AWS really fast, and you're like, no, it doesn't meet the security standards. Just put it in another account. Sometimes the business has a need to move forward. Put it in another account and then work towards getting it up to your standards. Another thing you might need a separate account or a separate networking environment for would be PCI compliance or HIPAA or PII data. You're trying to really protect a certain piece of data, or you want to limit the scope of your auditing, hopefully not to limit your security, but just there's a cost associated with this auditing. So maybe you put that in a separate environment. And when you do create all these networks, however, you need to keep in mind there are additional costs for peering, and there's different, and also for data in and out of AWS. So if you're on the same VPC, you don't face that cost. When you start breaking everything down, now you got to consider all these additional costs for data transfer. To me, that's the cost of security, however, in some cases. So here's an example. This is not, the be-all, end-all. This is just one example. You may need to structure your network differently. But in this case, we would say, okay, we have developers that have certain permissions, so they need to be in their own environment. We have QA people that have different permissions. We have a staging environment. We want that to mimic prod. We want it to be clean and pristine, so we're going to put that in one environment. And you may have performance test people who deal with prod-like data that other people won't get access to. And then you have a production environment. In production environment, maybe the people can't change the code that's being deployed, but they have access to keys and other things, and they can go in and troubleshoot. So you could put these all in one account and create really extensive IAM rules, but it might be easier just to separate them out. And then you have this bottom account here, and this is where I was talking about your deployment system is really where things can get into your network. So think about that. This deployment environment right here is connected to dev, QA, staging, prod. So if you have some rogue proxy going back and forth, essentially it could tunnel its way over the prod. So you have to think about how all these things are connected and how you're controlling them. I would highly recommend, if you can, to use a direct connect or a VPN. Direct connect will be a private line, so it won't be on the internet. Other people can't get onto that line, it's just yours. VPN will be going over the internet, but if you use an IPsec VPN, it will hide some of the implementation or the details in the network packets down at a lower level. It's be at layer 3 instead of layer 7. SSL VPN, still good. It will hide some implementation details, like you don't want to expose your endpoints directly to the internet if you don't have to. It will hide some of that information for you and keep your line private. If possible, I would use an IPsec VPN, but you have to think about where that VPN ends. You still have traffic going all the way to those endpoints, and so I would say use both if you can. So an IBM report finds that human error contributes to 95% of all security breaches. So what can we do about that? We can automate. Now, I've worked in an environment where security people who are new to AWS, maybe all you guys know this, but they didn't understand what that meant. And automation includes automating deployment of all your security appliances on AWS, your AD servers, your DNS servers, everything. And so this is just one example of some automation. It's something I've been playing around with, and it's installing a WatchGuard Firebox cloud, but you could just take that Firebox cloud out of there if you want to deploy something else that's a NAT configuration right now. You could change this code up and do something else with it. But if you're just getting started, which I'm guessing most of you aren't, but if you are, you could use this. Or if you're looking for an idea for a security appliance and how to install it in an automated fashion, you could try this out. Also wrote a paper on event-driven security. So I know we've talked about security here a lot, so if you've been here a lot, you've already heard this. But basically, when something is doing something bad and it's a common thing that you know about, you can automatically respond to that event. So in this case, this paper talks about setting up a honeypot, and then I just forced some bad traffic to simulate something bad happened, and then basically did a snapshot of the instance, and then shut it down and start up a new one. Then you could take that snapshot of the instance and you could put it in a secure environment where you want to look at it. Perhaps you're looking to see if it had malware on there or something like that. So we can do a lot more with this event-driven type security. And then, of course, the most important thing is monitoring and reporting, because we won't be able to catch everything. It's just not going to happen. I took the SANS boot camp, and there's a professor there that says, prevention is ideal, but detection is a must. And I really like that statement. We have to be looking at our logs to figure out what's going on, and there are a lot of tools for doing this. I have them listed here. We have VPC flow logs. You can feed all your data to CloudWatch, Elasticsearch, QuickSight, third-party tools. The picture here is WatchGuard Dimension. It is an award-winning network product that works with our fireboxes. But you can take the tool of your choice, just look at your logs, know what's going on. Just a note for anyone who's interested, you can capture packets on AWS. Some people thought you couldn't initially. You have to do it differently. You can't use a spam port, but I'm going to be writing a paper on this and demonstrating this. It is possible. And finally, we should all be working together. I think it's really important for people to help each other and share data, because there are events in the network which on a single network may not seem like a big deal, but when you correlate that data over many different networks, you can find trends and patterns. And WatchGuard writes a security report. We should start doing this. This is my team, but there's other things in my slides. This is driven off of data from our customers that allow it to send data back to us so we can analyze it, we can make our product better, we can find new malware. But there are other things in here like the SANS Internet Storm Center. There's a really good Verizon data breach report. So you can take a look at those, and really important that we're all working together and sharing our logs. So thank you, that's my talk. And again, I'm the Director of Security Strategy and Research for WatchGuard. I am on Twitter if you want to follow me, and you can DM me questions. I've had some people not being able to see my account, so if you do have that problem, please email or contact support at Twitter. And finally, I have my slides out there, and I will show them on the Meetup group. Thank you. Any questions? Oh, so you remember that packet that I showed you with the hex, and I said that's a network packet? So there are different, like, VPC flow logs is capturing basically network data, so it'll tell you your connections to and from, but it won't give you the full packet. It won't tell you the contents of the packet. And so there are ways to capture the full packet and correlate those things, and there's a lot of information you can find. If you go into, if you take a SANS class, there's an intrusion detection class where you just basically go in and like read packets, convert hex. It's really fun if you like that kind of thing. Anyone else?
Okay, thank Teri again. And then why don't we take just a few minute break while our other presenter gets set up.